So here is differential equations. The part of Dr. Allan-David, which is differential and difference equation. So I hope I'll be able to cover both in this video, just briefly though, and also majorly the calculation aspect. So I will encourage that you read the note aspect so that you'll be able to get it well. And also sometimes, according to past questions, sometimes you may have to do some questions that will require the knowledge of the note aspect, but this is the calculation aspect. And also I plan to write it out, to be solving and writing it out, but time is definitely against us, so I'm just going to use it directly from the material itself. So, and the two materials I'm using here is Schramm's. This is Schramm's, and also Alfasciang, Fundamental of Mathematics, something like that. So this is Alfasciang, this is Schramm. So the both of them are now currently on differential equations. So under differential equations, we have the first order differential equation and we have the second order differential equation. Under difference equations also, we have the first and second order difference equation. You'll be hearing similar terms under them too, but differential equation is totally different from difference equations, and they both actually just require formulas majorly. Yeah, you have to understand the concept, but you have to know quite a number of formulas, which they are not difficult to know actually. So let's start with differential equation, and we are starting with first order differential equation. Now one thing to notice, I said earlier we are using two textbooks here, two material, Schramm's and Alfasciang. Now the method for first order differential equation is a little different in Schramm's, and it's also different in Alfasciang, but I advise you use Alfasciang based on two reasons. The lecturer actually used the method in Alfasciang 1, and Alfasciang method seems shorter and a little less complicated. But for Schramm's, the method is also good. You still get to the same final answer, but the issue is that it's not the one the lecturer used, and also a little complicated because you have to do integration and some other stuff like that. So that's why I'm advising that you use Alfasciang, but the both methods are very good, very good. So that's that. And I am only referring to the first order differential equation. When it comes to second order differential equation, or either first or second order difference equation, you can use any of the two textbooks, any of the two material, because the both of them are the same method. So, and you can use both also. I advise that too if you have the time. So let's start with first order differential equation. So I am going to be starting with how can we know the order and degree of differential equations. How can we know the order and degree of differential equations? Now the order of differential equation is actually referring to the highest order. What do I mean by that? The order, even we are doing differentiation, you should have had something like first order differentiation, second order differentiation. When we say first order differentiation, we differentiate just once. Second order, it means we differentiate more than once. That means after differentiating the first time, our answer will differentiate it the second time. Third order, the answer from the second order will differentiate to the third time. So that's actually order of differentiation. We are applying similar instances here too. That's what we are doing here too. We are applying similar instances. So the first order differential equation, just like in differentiation, the way we write it, whenever we are let me highlight something here. Okay, whenever we are doing differentiation, whenever we want to do like second order differential equation, you'll notice that our 2 representing second order differential equation is always after the D. It just means to show the order of differential of the equation. Now it's actually different from when we have the power outside like this. So can you see we have the power after the d? It's different from when we have the power outside like this. So the order is the one after the d, meaning this one is means that we are doing the differentiation twice. After the first one, we do it the second time. So that is how we actually recognize the order of our differentiation, of our differential equation. So in this first question, what is the order and what is the degree? The degree is basically the power of that particular place where your order is. Okay, let's just take the examples and understand it better. So we have dy dt is equal to 2x plus 6. Now this is first order and first degree. Why? Basically because we are just differentiating once. Can you see there's no value after the d, and also there's no power after the y dt itself. So it simply means the order is 1 and the degree is 1. Going to the second example, what's the order, what's the degree? The order here is 1. Why? Because there's no power after the d. So the order is 1. But the degree is 4. Why? Because after everything, we have a power of 4. So that's why we have first order, fourth degree. Then moving to the third, what's the order, what's the degree? Now the order here is 2 and degree is 1. Why? The order is 2 because there is power here. Mind you, there is power here too, but it's a power of 1. But the issue is that whenever you are to find the order, you are taking the highest one. So ignore that one and take these 2. Now what is the degree? We might have thought the degree will be 3. No. The degree is always following the order. So because this is where the order is, your degree will be anything outside of this, which is 1. So that's why it's first degree. So we are not taking this highest for degree. We are only taking the highest for order. So whenever we now want to find the degree, we now follow whatever where our order is placed. That's where our degree will also be. So the last one, number 4. What is our order? What is our degree? Now our order here is third order. Why? Because we have 2 here, we have 3 here. So 3 is the highest. So we go with 3. 3 is our that's our third order. Then what's our degree? We have 7 here, we have 5 here. We are going with anyone with our order, which is 5. So that's how we got 5th degree. So that's just for order and degree. In case you miss it, in case you meet us in exam or so. Let's now go majorly into what we are going to do in differential equations. So I'm going to switch to Alpha-Chang. So here is Alpha-Chang. So in differential equations, we have a particular formula which we are following. Now that formula is this. This one here for differential equation. This is the formula we are following. Now this formula, this part of the formula, this part here, sorry, not that whole part, this part here before the e can also be represented with just a. So we are now going to have a e raised to power minus at plus b over a. So take note of that. So this can also be represented as a. So there are some questions whereby you are just going to use a. There are some questions whereby you use it in full this way. So we are going to touch both of them briefly. So that is that. Another thing to notice in your differential equations, it is always of this form: dy dt is equals to dy dt plus ay or some with my mass ay equals to b. So that's the form of a differential equation. dy dt plus ay equals to b. Now this a and this b, most of the time they used to be like a constant number, 1 2 3 4 5, like that. So in your question you'll be given this something like this. It can be rearranged, can be scattered. Just make sure you arrange it back. The one with y is the one that have a. The one that does not have y is the one that is b. So make sure you rearrange it. That's the first thing to take note of. Whenever it is scattered, make sure you rearrange it. And the sign here is coming with this a. If it is plus, that's plus a, which is the same thing as just a. If it is minus, that's minus a. So this is the form. Now in our question, sometimes you'll be given this y0. That means y at 0 when t is 0. Like so when you are given that is when you use this full formula. But if you are not given y0, that is when you just remove y0 minus b, remove everything and put a. A you won't be given. It means your answer will probably or definitely carry a. So you won't be given that a. So that's what you should take note of. If you are given y0, you will not have a. You just put whatever you are given in y0. So they can tell you that y0 is 20, y0 is 5, y0 is 8. So you just put 8 minus, then you continue your work. But if you are not given y0, just replace everything here with a. That's it. So let's continue now. Let me delete all this. Now, so we have a question here in our example here. We have to solve the equation, this equation, dy dt plus 2y equals to 6. So if you look at our form, I've actually cleared it off. Our form, this is following our form. This is dy dt plus ay equals to b. Now here our a is basically plus 2, which is this 2. Our b is now 6. So that's what they are telling us here. A is 2, b is 6. Now we are giving y0. So we are definitely using this full formula. We are not changing it to a. We are giving y0 as 10. So we are good to go. So using the formula simply say our answer, which is our general solution. Yeah, take note of that. Our answer is called the general solution. Now our answer is equals to y0. Y0 is what? 10. So we have our 10 here. Minus b over a. B is 6. This is b. And a is 2. It simply means 6 divided by 2. 3. That's how we get this 3. Then our e gets to power minus 80. 80 simply means this t will be there. It's kind of an unknown there. You don't need to change t. You are not even given t, which you won't be given in most questions or in all questions. But our a is 2, so we are going to have minus 2. Take note, a is 2, not minus 2. But the formula have minus, that's why these two have minus. Then plus b over a. B over a is still 6 over 2. So that's how we get this. So we have 10 minus 3, that's 7 e raised to power minus 2t plus 3. So this is our final answer. You can't go beyond this. So this is our final answer. So can you see that it's actually a short, direct solution, majorly if you know the formula. So that's basically it. And I think the best way to know formula in mathematics is not to cram it. For me, actually, there are two basic ways to know formula. Number one, which is like the hard part, is to know how to prove the formula. So most of the time the proving used to contain so many complicated stuff. So that's why I said it is the hard part. So if you can prove the formula, like a quadratic formula, if I could know it, I have to like learn how to prove it. So but I think the best way, which is also easier, and also even if you learn how to prove it, if you want to like know it permanently or know it for a long time, you still have to use the second method, which is practicing questions. That's just basically the rule of math. if you want to know it, just keep practicing questions. So you don't need to cram this formula. I'm very sure if you try to solve as many questions, probably from Shams or this Afashan, you try to solve 15-20 questions, and trust me, 15-20 questions will not take the whole of your time. It probably may not take more than 1 hour of your time, so which is still a very, very good timing. So if you solve 20 questions, 30 questions, I'm very sure this formula will stick. It's going to stick. So try as much as possible to do as many questions as possible, unless you just assume you know it. Yeah, you know it at this point, but if you want to try it again the next few hours, the next day, you might now realize that you cannot even remember anything from what you have learned. So that's just a tip, by the way. So we have another question here, which is giving us dy dt plus 4y equals to let me see, can I clear everything at once? Yeah, good. Dy dt plus 4y equals 0. So you can just take a break and try and see, can you recognize which one is A, which one is B? So A is actually 4, B is actually 0. Our y at 0 is 1. So we are doing y at 0, so we are still using this full formula. So we are now going to have it as 1, which is our y at 0, minus b over a, that's 4 divided by 0 divided by 4, which is 0, e raised to power minus 80, a is 4 minus 40, plus b over a is still 0. So the answer will now be equals to e raised to power minus 4t. So that's just as simple as it can be. So I don't think that should be an issue for us. So let me try and see if I can see a question. Let me clear this first. A question that we are not giving y at 0, so that we will know how to fix it as a. Okay, I think these two we are also giving y at 0, but let's give this also a try. So in this particular question, it might look a little confusing that we just have dy dt. There's no, normally we used to have plus ay, but now there's nothing showing ay. It's not supposed to be equals to b. Definitely these are two should be our b, but what's our a? A simply means 0. Since we don't have ay, it simply means that a is 0. So just take note of that. So your formula still remain the same. You still use the formula, but a here is just 0. So that's basically what I want to explain here. So you can try it out yourself. So still in search of a question, okay, that we are not giving. I think all the questions in Afashan basically give us 0. It's only when we come to Schwamms they are going to miss questions that we are not giving y at 0. So at that point we are just going to use a directly. Like in this question, for example, in this question, where is the question? Yep. So this example theory now, I think we did something similar in Afashan though, but let's just take it. This example theory now, we are giving this, but we are not giving y at 0. So remember, don't follow this solution, because this is actually another method. It's not bad. That's also a good method. You still get the same answer, but that's not the method the lecturer is using, and it's a little much longer solution than the first one. So let's try and use the first method to solve this. Dy dt plus 4y is equals to 12. These are our a. 4 is our a. 12 is our b. Now we are not giving y at 0. It simply means instead of using this long formula, the long formula y at 0 blah blah blah, you are just going to use a e. Don't mind my writing. I'm not used to writing with mouse. This one minus a t then plus b over a. So that's basically it. So what I'm saying is that instead of you using this long one, just replace everything here with a. So that's basically what we are doing. That's basically what we are doing here. So this is the formula: ae raised to power minus at plus b over a. Now this capital letter A we won't be given, so the answer will just remain as A. Then E2, we cannot change E is Euler, minus AT, A is our 4, T2, just put your T, plus B over A, B is 12, divided by A, which is 4, that's plus 3. So this is our final answer. So can you see all these story these guys are saying? We have just gotten to our final answer in 2 steps. We don't have time for story. So that's it, as simple as that. So I hope that is gotten, and that might be simple. Just make sure you try and practice questions, then you find it actually really simple in exam hall. But if not, good luck though. So we move on to second order differential equation. Yeah, in Schwarm's actually, also in maybe Alpha-Shank, you may see some other stuff. I believe in Alpha-Shank, what you basically need is to just read some other parts. So that's basically the basic. Read some other parts to help you boost it up. Time is not with us for us to do every part, but in Schwarm there is actually a very large topic which I want to try and believe we definitely are not meant to do everything here. Probably the rest are for year 4. So they are just what I want to believe, because our course outline did not specify which part of it we are going to study, but the whole topic is very large, very large. So I'm just going to ignore all of that so that I won't waste time doing things that might not be necessary, which I'm a little sure is not necessary. So we go to the second order differential equation. So it seems I'm going to stick to Schwarm's for that. So for second order differential equation, don't worry, Schwarm's and Alpha-Shank is more like the same thing, so you have nothing to worry about for that. So if you prefer to use Schwarm's, I prefer to use Schwarm's because Schwarm's has a lot of questions that I can practice with, and remember, the person that passes the question is the winner in maths. So practice the question and you do wonderful well. But Alpha-Shank have limited questions, so I don't prefer using it, but it's also a very good textbook material so far in mathematics for economics. So I'm going to second order. This is differential equations. Okay, let me just scroll down. So I'm going to second order differential equation, which I have here. So second order differential equations and difference equation, but I'll do only differential equation now. Then by the time we do difference equation first order, we'll come to second order. It seems the video will end with just differential equation. I'll find time to do difference equation once again. So this is a second order differential equation full of formulas, simple formulas though. So in second order differential equation, the form, remember in first order differential equation, remember how did I say the form will look like? If you can get that, yes, color already. dy dt, remember that dy dt sometimes they can just write it as y. Is it prime? I'll call this, I don't know. So dy dt plus ay equals to b. So that's first order differential equation. That's how it looks like. But second order, this is the new look of second order differential equation. So instead of just y 1 prime, we have y 2 prime, trying to tell us that second order. So y of t plus b1. Now we don't have just a and b again. We have 1a here, but we have b1 and b2. So b1 y prime t plus b2 yt is equals to a. So that's the form of a second order differential equation. So your first aim is to know what is our b1, what is our b2, and what is our a. That's your aim in your questions. So whenever you see your question, that's what you are targeting. Now, what is our formula, or what are our formulas for second order? We have some formulas for second order. The first one is, yes, I forgot to mention this. In first order differential equation, from our answers, we have something we call complementary function. Complementary function and integral, particular integral, yeah. So let me use something from Apache to show us as example. Complementary function and particular integral. So for my examples here, after getting an answer, this is actually what we call the complementary function. This guy here, this 7e minus 2t. Why? After this plus, or this plus and this is what we call the particular integral. This complementary function, sometimes it is written as y of c like this, and particular integral is written as y of p. So the general solution is actually comprising of complementary function and particular integral. So from here, our complementary function is this, our particular integral is 0, because the 0 means nothing. That's why it's not showing this answer. So that's by the way. So that's what leads us to second order. Now, in questions in first order, sometimes they will ask you what is the general solution, which is y of t, which is what we have just done. But after asking that, since it's theory, they might ask that, okay, from the general solution, which one is the complementary function, which is this one, which one is the particular integral, which is this one. But in most cases, they will just ask for general solution directly, and if they feel like they cannot ask for y of c and y of p. But in second order for differential equations, which is also similar for differential equation, in second order, most times they will ask for the particular solution and the general solution, particular integral and the general integral and the general complementary integral. They will ask you for the particular integral and the complementary function differently. If they now like, they will now ask for the general solution, which is addition of the two. So first order, most of the time they ask for general solution, before they now come to complementary and particular. But in second order, they ask for complementary and particular, before they now come to general solution sometimes. If they now ask for general solution, they are good, just do complementary and particular for them. But if they have for general solution, it's actually the addition of complementary and particular for second order. Now, from these questions, from this particular one, these are formula for particular integral, which is the second one that used to be at the second side, at the right hand side. So at the right hand side we have the particular integral. So the particular integral is basically y of p is equals to a over b2. This a divided by b2. That is just how to find your particular integral, as short as that. But that is if only b2 is not equals to 0. If b2 is equals to 0, this will be giving us a funny answer, so that y b2 must not be equals to 0. So if b2 is not equals to 0, once this b2 is not equals to 0, it simply means a over b2. But in case this b2 is stubborn and it is equals to 0, then we will not use this formula again. Then we'll come to this one. So you don't need to use the 3 formulas at the same time in one question. No, just need one of them. So if b2 is not equal to 0, which is mostly the case, you use this. But if it is proven stubborn and it is equal to 0, you are going to use y of p is equals to a over b1 t. This one has t. That's also if b12 is not equals to 0. If b12 becomes 0, this will also be funny. So that is why we use a over 2t squared whenever b2 is not equals to 0. Whenever b1 is equals to 0. So if b1 and b2 is equals to 0, we just use a over 2t squared. So that's what we are going to use for particular integral. That's for particular integral. So we now go to complementary function. How do we find our complementary function? Let me clear off some things. So let me all this again. So how do we find our complementary function? To find our complementary function, which is the first part, the left hand side of the equation, the general solution, we actually have it as our y is equal to y1 plus y2. But the question is, what is y1 and y2? We have not been using y1 and y2. Where are they coming from? So y1 and y2 to also have their own formula. y1 is a1, a, which is that capital letter A we normally don't change, e raised to power r1t. y2 is a2, e raised to power r2t. The both of them are still the same thing though. It's just that one is carrying one is carrying 2. But the question still remains. Yes, we know t is one of our answers. It's going to just remain as t. But this r, what is r1 and r2? That is why r1 and r2 to have a formula. Yeah, I know it's getting complicated. Yeah, but it's simple. Just show. So we actually have formula inside formula in this. In our complementary function, we have it as y1 plus y2. Our complementary function is simply y1 plus y2. And y1 is a1 e raised by r1t. y2 is a2 e raised by r2t. So we can simply say our complementary function is equals to a1 e raised by r1t plus a2 e raised by r2t. You can say that directly. You are good. But how do we get our r1 and r2? That is where this guy comes in. Our r1 and r2 is minus v1. It looks like that quadratic formula. Remember, our quadratic formula is minus b plus or minus b squared minus 4ac over 2a. The difference is just these guys. Instead of 4ac, that ac, remove it and put b2. Then instead of 2a, we only have 2 here. That's the difference. Now, r1 and r2 are not the same thing. Although the both of them are sharing the same formula, they will not give you the same answer. So how will their answers be different? Just like quadratic formula, when you get to a point, you have to separate this plus and minus. So when you get to a point, probably this one is 10, this one is 4, this one is 2. Then when you get to a point, you are going to say 10 plus 4 over 2. That's for r1. For r2, 10 minus 4 over 2. So one will take the plus, one will take the minus. We are going to see it in an example here. So that is the complementary function. And this is the particular integral. The particular integral is the one that have if b is not equal to 0, if b is equal to 0, blah blah blah, things like that. So let's take an example. Okay, let's move on. Let's take an example. The complementary function for equations 1 and 2 in example 1 are calculated below. Okay, so we are given an example here. We are told to find a particular integral for each of the following. If they ask us to find particular integral, I'll be so happy, because that does not actually have all this long formula, but it also have its own long formula, because you have to know 3 formulas actually. So in case b2 is not equal to 0. So don't say b2 will always be 0. You just gonna store one formula. It may be our time that b2 will not be 0 again. So that's why you have to know all the 3 formulas. So this is actually a different question. So we have 3 questions here. We are now to find the particular integral for each of the 3. We are now asked to find general, so we are not using all these guys at all. We are now asked to find general solutions, so you don't need to add the 2 together when you are done. So we are to just find the particular. Now from here, what is our B1, what is our B2? Remember our general form. This is our B1. Yeah. Voila, wow. So this is our B1 minus 5 alone, actually. No y, blah blah blah. Then this is our B2 plus 4. This is our A in this question. Now our B1 is minus 5. B2 is plus 4. Now let's get back to our formula here. A over B2. If B2 is not equal to 0. Now B2 here, let's check it, is plus 4. I can still remember. So it's definitely not equals to 0. So since our B2 is not equals to 0, that formula is very valid. So we are going to say our particular, y particular, is actually A over B2, which is 2 over 4, which is 1 over 2. That's how we get this. So as simple as that, we are good. So that ends that question. We go to number 2. We have to find the y particular integral for this too. The question still goes to, well, it our B1, what's our B2, what's our A? This is our B1. The B1 is the one for this y1 differentiation t, the first order differentiation here. This is second order differentiation. Let me just use one differentiation, don't go and confuse it. So that's our B1. Our B2 is the one that does not have any differentiation here, which is 4 in this aspect. But here it is missing here. Simply means it is 0. So going back to our formula, B2 is 0 now. So you cannot use this formula. So you have to use the second one. So this second one says A over B1 T. So which is what we did here. A is what here? 12 over B1, which is 3. 12 divided by 3, that's 4. Then T in front, that's 14. The third question, here now, what is our B1? No B1, it is 0. What is our B2? No B2, it is 0. What is our A? 16. So the third equation is what we are using, because B1 is 0, B2 is 0. So our A is the only thing that we have. So this is the formula we are using, A over 2t squared. So what is our A? 16 divided by 2, 8. Then you put t squared in front. That is particular solution. As simple as that. Yeah. You know that is simple, right? Let's hope we see it. So we go to the next question. Next question I say we should find the complementary function for each of these guys. So when you want to find the complementary function, the most important thing is the R. Everything is important though. So the R is quite very important. So that's why they are starting with R. Remember, the complementary is the one that have this A1 e raised by R, e raised by e r raised by t, blah blah blah, things like that. So the complementary actually have A1 e raised power rt. Take note, rt. They have done some solution here, that's why you are not seeing the R. Let me show you up here. Don't say we are doing magic. So this is it. Can you see R1t, R2t? So they are basically the same thing, just like one is 1, one is 2. So but the first thing you have to do is to look for your R1 and R2. So that's why they started from here. So how do we get our R1 and R2? This is the formula here. Let me see if I can peep. Let me zoom out. So that I can see this formula. This is the formula here, and this is what we want to do. So our R2 is actually minus B1. Minus B1. What is our B1 from this question? Remember, these are B1, these are B2, these are our A. So B1 is minus 5. So we are saying minus times minus 5. That's how we get for plus 5 here. Minus side minus plus. And that plus or minus square root of B1 square. What is our B1? That's still minus 5. Minus 5 square is 25. It's not minus 25. Take note. Minus 5 square means minus 5 times minus 5. Minus times minus plus 5 times 5, 25. So we are good to go. So that's how we get minus 5 square, which will give us 25 here. Let me just put the 25 up here. Sorry, my alarm. Shut up. So we have 25 minus, so we have 4 times b2. That's 4 times, what are b2 here? 4 times 4, that's 16. This may be the only example we are going to do. This video is meant to be 30 minutes. So 4 times 4, that's 16. So we now do 25 minus 16. That's what we are going to be having here now. So 25 minus 16 is actually what? 9. Square root of 9 is 3. So that's why they get the 3 here. So this 5 here, now in be this. Then the plus or minus is in the middle, everything over 2. So you are now going to separate it. It's not going to be either R1 will now be equal to 5 plus 3 over 2, and R2 will be equal to 5 minus 3 over 2. So you don't set like that. So 5 plus 3 over 2, 4. We'll forget about these guys. They put 1 first, 1, 4, 4. I prefer to do the plus first. Well, in their second example, they did the plus first too. So I don't know, maybe it matters either it's plus first or minus first, but I prefer plus first. And in most of the examples they also did plus first, but in this particular one they did minus first. Probably a mistake, or probably doesn't matter, but to be on the safer side, do the plus first. So you can realize it matters after they mark your script, please. So we have 5 plus 3 over 2, that's our R1. The R2 is 5 minus 3 over 2, that's our R2. Now don't be too eager or too eager to leave the question. You are not yet done. So that's just for R1, R2. So you come back to your equation and put it in it. So our equation says E1 ER1T plus E2 ER2T. So A1 is A1, so you are not changing that one. E is E, but that R, it is 4. So that R1 it is 4. So it is 4 that will come first for me, because we did plus first, not minus first. We are going to have A1 e raised to power 40. That's what we are going to have, plus A2 e raised to power 1t, which is the same as t. That's the one they did first year. So this one will come first for our own, this one will come second. So that's just your final answer. As simple as that. This is your final answer. Let me highlight that. This is your final answer. So as simple as that, and you're good to go. So the solution whereby they now ask for general solution. Remember what we did at first year for this number 1. This particular, this complementary. If they now ask for general, you are just going to say everything here like this, plus this 1 over 2. That's your general solution, and that's it. And that's the end of second order differential equation. So I think you are going to stop there. There are other examples you can practice. There are many other questions in terms that you can attempt. It's going to like brush you up and prepare you for the exam. I wish you good luck. So I drop my pen here. Thank you.